Hi everyone, this is the beginning of chapter 4, and these two sections are about ratio and proportion. So first we have to talk about what am I talking about when I'm talking about a ratio. It's a comparison of two quantities of the same kind, both usually expressed in the same units. So here's a few examples. Gear ratios, right? The driven gear A to the driving gear B. 64 teeth to 16 teeth, and then of course you would simplify that, and it is 4 to 1. Now we can write a gear ratio this way, or with the word to, or with a colon. All of those mean the same thing, that we're comparing 4 teeth on one gear to 1 tooth on the other gear. Same thing with the pulleys. Notice we have the diameter of each pulley, and we have 21 inches to 9 inches. And then if we simplify that, when simplified, it ends up 7 to 3. And we can write it either way because 21 and 9 are both divisible by 3, so they simplify. And on this last one, we have 7 feet to 24 feet. But because we often want the pitch of a roof to be written with a 12 in the denominator, we're not going to simplify that quite as far. So if we divide them both by 2, we get 3.5 to 12, and then that is about the pitch of a roof. All right, a proportion. So we use ratios to set up proportions. A proportion is an equation stating that two ratios are equal. And so if we have a ratio, we can say this one equals that, and that's called a proportion. So notice that I have 1/3 equals 4/12. Well, those happen to be equivalent fractions, like 1/3 is equal to 4/12. And so if I were to cross multiply, I would get the same thing on both sides. And you can also look at this as 1 is to 4 as 4 is to 12, because that's how you can state a proportion in words. Now, if I did cross multiply those two, I'm going to write this out over here so we can look at it. If I took 1 times 12 and 3 times 4, then I get the same number on both sides, showing that it is equal. Now, normally when we're solving a proportion, one of those is a missing part. We'll have an X there or something, and so we solve for that missing part. And we do that by finding cross products. So cross products mean that I'm multiplying on the diagonal, right? So on this you can see A times D is equal to B times C. So if you can think about just, if I multiply the cross products and set them equal, then I can solve for whatever part is missing. Here are a few examples to practice with. So we're going to practice finding the cross products. Now you have to write this. This is an equation, right? A proportion is an equation. So on my next step, I need to have an equal sign. And so you just take one cross product and put it on one side, the other cross product and put it on the other. Now a lot of times you might want to put the one with the variable here on the left, and then I take 27 times 0.8. I'm going to write that out just on this step. Normally we just go ahead and multiply that out. So that equals 21.6. And then we divide to solve. So when I say we divide to solve, it's because we're solving an equation, and this is 3 times m. So if we divide both sides by 3, I think I'm going to change colors here. I divide both sides by 3, then my solution is 7.2. Now, the nice thing about solving proportions is it's very repetitive, right? We find the cross products, we divide by whatever numbers with our variable, and it's always going to be the number with the variable, and then we find our solution that way. So you're going to like that part of it at least. Once you have it set up, then the solving steps are the same every single time. Now on this next one, we can write these as decimal numbers. We don't have to leave them as mixed numbers. Mixed numbers are kind of clunky, especially if you're trying to enter those on your calculator. And all of these are nice numbers like 2 1/2, 1 1/4, 3 3/4. So the cross product here is going to be 2.5 times 3.75. And then my other cross product is going to be 1.25 times r. So we do that cross multiplying, and then of course I have to go ahead and multiply out the 2.5 and the 3.75, so that's 9.375. We always divide by whatever number's with our variable. In this case it's 1.25. So the number with the r, that's what we divide by. And we find that r equals 7.5. Now you might notice that I turned this around and wrote the r in the left. You don't have to do that, but it's perfectly fine because these are the same, right? I can write it this way, or I can write it with the r the way I did on the first one. Okay, so here's our next proportion to solve. We are going to cross multiply again. Now, I want to show you a little bit of a shortcut. This is something that you can do, but when showing work, you know, there always has to be work to show. Since we know we're going to multiply this and then we're going to divide by 1.5, you could say A equals 3.25 times 0.6 divided by 1.5, right? Because 1.5 is the number that would be with the A. The 3.25 and 0.6 are the two that we multiply, and then you can just calculate. All right, so we get 1.95 divided by 1.5. Trying to write better here. And I end up with 1.3. Now, of course, you can show the cross multiplying in the other way. I just wanted to show you this is true every time. Multiply the two numbers that don't have a variable, divide by the number with the variable. It will work every time. I'm okay with you taking some shortcuts as long as you show me something, right? You've got to show me what you were doing and not just an answer. Also, I want to say that if all I see is this, right? You show this and then you give me this answer, that's not enough, okay? Show me some solving steps, and I will consider that showing your work that way. All right, so applications. So we have some applications coming up of proportions where we're going to set them up and solve. And these first ones that we're going to talk about are called direct proportions. Now it's important to be able to recognize which one is which, because when we get to the other part of this lesson, we're going to talk about inverse proportions. So we have direct proportions and we have inverse proportions. So you have to learn to recognize which one's which, because it's not always going to tell you. So direct proportions are increasing with both quantities or decreasing with both quantities. Now, if you actually say this to yourself, as this increases, what happens to this? And you can decide, oh, are they both increasing or not? Are they both decreasing? Now, if they're doing the opposite, that's where we're going to start with those inverse proportions that are coming up in a bit. All right, this is a welding problem. A 10-foot bar of I-beam weighs 208 pounds. What is the weight of a 6-foot length? Okay, so we're comparing a 10-foot length to a 6-foot length. If you will actually always start out by comparing the two parts that you know and that are the same, like these are both I-beams, then setting it up that way will help you as you work with direct and inverse. So what I'm saying is, write one side of your proportion as 10 to 6. Notice both of these are feet, right? 10 feet and 6 feet. Now we don't need to write the feet in there, but we are comparing those two things. So we have a 10-foot beam compared to the 6-foot beam. Now on the other side, it tells us that our 10-foot bar is 208 pounds. So we're going to write the 208. And then we're finding the weight, right? What is the weight of the 6-foot length? So we're looking for the weight, and we're going to call that X. Now, both on this side are going to be in pounds, and the other side was feet. So I put those quantities together. This is not the only way to set these up, but this will really help you for inverse if you'll set them up this way every time. When we cross multiply, then we get 10x equals 1200. 6 times 208, you say that is 1248. And then divide to solve. And x is 124.8 pounds. Now, you always want to look back and say, did this make sense? Okay, my 10-foot was 208 pounds. Now I have a 6-foot, it's 124.8. That seems fairly reasonable, and so we can go with that. All right, here's a roofing problem. So in this one it says for a given depth, the breadth of a beam needed to support a roof is directly proportional to the width of the roof. If a 4-inch beam will support a 48-foot wide section of roof, what breadth is needed to support a 72-foot wide section? So the two parts that we know are the 48-foot and the 72-foot. And that's the width of our roof. And then it was a 4-inch beam for the 48-foot. So we're going to put that in the numerator, right? Because it's going to be across from that 48. And then we're looking for, right? We're looking for how many inches the beam will be to support the 72 or the 72 feet. Once again, we cross multiply, so we're going to have 48 times x and 72 times 4, which is 288. We divide to solve, and we find that our solution is 6 inches. And then if you look at this, this makes sense, right? 4 inches for the 48 feet, 6 inches for the 72 feet. Okay, let's see. I think we'll stop here. I'm not sure we have time to finish the next example, and then I'll pick this up on the next video.